Come back. Problem 3. Test the claim that the population of sophomore college students has a mean grade point average greater than 2.15. So, your null hypothesis is that mu equals 2.15 and alternate hypothesis is that mu greater than 2.15. Sample statistics include n equals 51. So you have a sample size of 51. Sample mean is 2.36. Now that's sample standard deviation of 0.9. In other words, we don't know the population standard deviation. They are asking us to use significance level alpha equals 0.05. Since we don't have this population standard deviation, we have to use the test statistic given by T. So the procedure is not when sigma is known, but the procedure is when sigma is unknown. So your test statistic is denoted by T, and you use now this formula, and don't forget degrees of freedom. All right. So using that information, I'm using this formula, right? And degrees of freedom here. Degrees of freedom is 50. What is degrees of freedom? 1 less than the sample size. That's degrees of freedom. So you put x bar minus mu over s over square root n, the same formula, right, with the standard deviation of your sample. Plug in x bar, plug in mu, s square root n, and you get this value. Now p-value is one-tailed because this is greater than, it is one-tailed. Degrees of freedom is 50. How do I get these numbers? So let's look for p-value using student's t-test, okay? So that's this normal one, and this is also normal. Here is student's t distribution. Degrees of freedom is 50. So degrees of freedom is 50, and notice we are looking at one-tailed because this is greater than. If it had been two-tailed, you would look at this row. Because it is one-tailed, you are looking at the top row. Degrees of freedom is 50. So that's 50. Okay. You are looking for a test statistic 1.6663. So let's look for 1.6663 on the row for 50. 1.6663. So that's the 6663 lives between these two numbers. This is 462, this is 676. So 6663 lies between these two numbers. So if I go up, and remember I am one-tailed, so here 0.075 and 0.050. All right. So that's where I have p-values between, my p-value lies between these two numbers. So let's keep that in mind. So between these two numbers, that's what I have written. So I'll write the smaller number first. That's less than p-value, which is less than 0.075. All right. Now, with that information obtained, question is, so let's look for this test statistic 1.666333. The p-value is between 0.050 and 0.075. All right. Now my alpha is 0.05. Okay. At this point, p-value is between these two numbers, right? Question is p-value less equal 0.05? That's the question. Well, it is not, because p-value is above 0.50, 0.050. So p-value is above this guy and below this guy. So all we know is that p-value cannot be less equal 0.0. So if p-value is not small enough, we do not have enough evidence to reject null hypothesis. Okay, so that's what we are going to say. Is there sufficient evidence? No, there is not sufficient evidence to support the claim that the mean grade point average is greater than 2.15. All right, that's correct. So that completes all the problems from section 9.2. So next videos will cover section 9.3. Until then,